Hi, welcome to the video on acidic, basic, and neutral salts. You will need your notebook for this video to record notes and write down example problems. So if you need to get your notebook, press pause and get that now. All right, let's start. So in this unit, we've been looking at solutions chemistry, the reactions that occur in solution. And there are two types, precipitation reactions and neutralization reactions. We're going to focus on neutralization reactions. That's where we add an acid and a base together and we get a salt and a water. So let's talk about what we know about acids and bases. Acids are proton donors. They donate H pluses, and they have a pH that's less than 7. Bases are proton acceptors. They have a pH that's greater than 7. And so the question is, if we add an acid and a base together and we neutralize them, will we always have a pH that's equal to 7? The answer to that is no. It depends on the acid and base it comes from. So let's talk about some pH neutralization rules. Here's where you're going to be taking down some notes, so get ready. So the pH of the salt that is formed depends on the strength of the acid and base. If we're mixing a strong acid and strong base together, our salt will be neutral. So the pH will be about 7. So for example, you have HCl, which is a strong acid, and NaOH, which is a strong base. You mix those together and you get a neutral salt in ACl. Now let's say, for example, we have a strong acid and we mix it with a weak base. What do you predict we will get? A neutral salt, an acidic salt, or a basic salt? So strong acid and weak base. Okay, so if you've guessed correctly, the acid's going to dominate, so we're going to get an acidic salt. That means that the pH of the solution is going to be more acidic, so it's going to be less than 7, which is what we see in this example here. HCl is a strong acid. NH4OH is a weak base, and it will form ammonium chloride, NH4Cl. And just so you know, this NH4OH comes from NH3. Remember when you dissolve NH3 in water, it forms ammonium hydroxide. And you can use these two interchangeably. They often are. But in water solutions, whenever NH3 is reacting, it's actually reacting as NH4OH. Okay, finally, what if we had a weak acid and a strong base? What do you think the pH of the salt will be? All right, correct. It will be a basic salt. So that's what we see in this example here. We have a weak acid, acetic acid. Vinegar is weak, and NaOH is a strong base. That means that the base is going to dominate and the salt itself is going to be slightly basic. So the pH is going to be greater than 7. Okay, let's do some example problems. So in order to do these problems to predict the pH of an acid-base neutralization, you need to know your list of strong acids and strong bases. If you don't have that written down in your notes, but you should, you'll probably want to write these down as you go along. So you can pause the video to do that in a moment. For these problems, you need to predict the pH of the of the neutralization reaction. But in addition, just for practice, I want you to complete and balance the equation for the following neutralization reactions. So complete and balance the equation and then predict the pH. Pause the video now, and then when you come back, press play again. I'll show you the answers. Okay, so go ahead and take a look at your answers here. For the first one, calcium hydroxide is a strong base. HF is a weak acid, so that's going to give you a pH greater than 7. It's going to be slightly basic. Lithium hydroxide and nitric acid, they're both strong, so you're going to have a pH of 7 for that one. And then finally, sulfuric acid and ammonium hydroxide. The ammonium hydroxide is a weak base, and sulfuric acid is a strong acid. And so the pH is going to be slightly acidic, so less than 7. Check your work, correct, and identify any mistakes that you've made. Okay. Now we're going to look at some example problems where you're given a salt and you need to predict its pH. This is a little bit more tricky than when you're given the acid and base because that's simple. You just determine if the acid and base is strong or weak. So in this case, what you need to do is you need to determine the acid and base that made that salt. And to do that, we follow these steps. So first thing is we break it down into cations and anions, just putting a line through them, sort of like through the middle. break the salt down to cation and anions. And then we turn the cation part into a base by adding OH. And the number of OHs will depend on the charge of the cation. And then we turn the anion into an acid by adding H+, and again, the number of H+ will be determined by the charge on the anion. Once we have our acid and our base, then we can just see if they're strong or they're weak using this list here. So let's do an example together. Before we do that example, go ahead and write down these steps, and when you press play again, we'll do the example. Okay, so let's say for this one, we're predicting the pH of the salt K2SO3. This is potassium sulfite. The first step is to break it down into its anion and cation. So we'll do this together, write that salt down. And then we're going to split this up. The cation is the potassium part and the anion is the sulfite part. All right, so I'm going to rewrite this cation. Potassium is a group 1, so it's a K+. And I'm going to turn that into a base by adding an OH. Now, since this is a +1 charge, I just need to add one OH minus. That gives me potassium hydroxide KOH. I look to my list, I see that that is a strong base because it's a group 1 base. So I label that. Do the same thing for the anion side, so try it on your own. And then when you press play again, you'll see what we got. All right, sulfite is SO3 2-. I'm going to turn it into an acid by adding H+. Now, since it's a 2- charge, I'm going to need 2 H+, so I get H2SO3. That is not a strong acid. It's not on that list there. Notice that this is sulfuric acid, H2SO4. And this is H2SO3, sulfurous acid. This is not the same thing. These are not the same. And so this is a weak acid. So now it's time to predict. So what do you think it'll be? You have a strong acid. This salt comes from a strong base and a weak acid. What do you think the pH will be? Great. The pH is going to be greater than 7. It's going to be slightly basic because it came from a strong base and that dominates over the weak acid. Okay, so make sure you get this example copied down in the notes along with the answer. And then when you press play again, I'll give you some example problems. Oops. Okay, sorry about that. So now for the next one, you're predicting the pH of the following salts. Write down these salts here into your notebook. And using the process that we just saw on the previous page, you're going to predict the pH of these salts. When you press play again, I will show you the answer. Okay, so here are the answers. I need you to check your answers, correct, and identify any mistakes. And then come into class with any questions that you have about this. Next class, we will spend more time preparing for our unit exam. I hope you found this video helpful. Have a quality day.